Hello everyone. So in this video and the subsequent videos, we are going to discuss about the functionalities of a MAC layer, in particular Aloha, CSN, ECD, CA, Ethernet token ring, flow control, error control, and other data link layer protocols like HDLC and point-to-point protocols. So let's get start with the data link layer. So the basic uh, basically the data link layer is divided into two sub layers uh, uh, and called as logical link control and medium access control, right? So logical link control layer has the responsibility to flow control and error control mechanism, whereas media access control will take care of the access, how to access the channel, how to control the channel, right? When to transmit, when not to transmit the data, right? So these things will be carried out by media access control layer. So these are the uh, two sub layers. So the data link layer will be divided into two sub layers, media access control and logical link control layers. In short, you can call it as MAC layer and LLC layer, right? LLC layer. So each sub layer has its own protocols, right? Uh, so data link control, uh, right? Data link control is a reliable channel for transmitting the data, right? Over a dedicated link, whereas for wireless, in case of wireless transmission, right, we have different protocols, right? So media access, multiple access protocols, right? Multiple access protocols broadly categorized into three types: random access protocols, controlled access protocols, and channelized protocols. Right? Channelized protocols. See, multiple access protocols, a technique used to provide access to transfer packets, right? Packets through a common medium, right? So irrespective of whether it is wired medium or wireless medium, right? Using a single medium, how to transfer your data packets without any collisions or corruptions, right? So, in order to transfer the packets to the destination without any congestion or corruptions, we need multiple access protocols, right? Multiple access protocols. So, these multiple access protocols, there are three broad categories of multiple access protocols. They are random access, controlled access, and channel. Again, further, these three types of protocols are further classified into different protocols, different types of protocols, right? I will be discussing these protocols one by one. So first one is random access protocols, right? Random access protocols are also known as contention based protocols, right? Contention based protocols. So the basic idea is no station or no device is superior to another device, right? So no priority will be given to any devices or stations present in the network, right? So no one is taking the central control or uh, uh, permission to transfer, right? So at any point of instance time, right? If you have a data to transfer, any station wants to transfer the data, uh, it will be free to transfer the data, right? Whenever you have a data to transfer, you can start transmitting your data without any permission, without any access, right? So it is based on the assumption that the data packet size is low, right? The data that needs to be transferred is low in size, and the channel is free, right? So random access protocol is based on the assumption that the channel is free or idle, right? and the data that needs to be transferred is low, right? So there are two important features in this method. See, there is no scheduled time, right? There is no scheduled time for a station to transfer, right? So whenever you have data, you can start transfer immediately, right? That's why we use the name random access. Second, there is no rules specify which station should send next. There is no scheduling, there is no rules specifying which station should transfer the next data, right? So the diagram will illustrate the operation of uh, normal Ethernet using Aloha protocols, right? There are four stations connected to a through a bus topology, right? So whenever uh, you have a data to transfer, so A wants to transfer data to B, right? So immediately it will transfer the data, right, to D through the medium, right? So the transmitted packets will be seen by all the stations that are present in the network, right? But the B and C will check the destination address, IP address, right? If it is matches with its own IP address, then the packets will be uh, received and processed, right? Otherwise, it will discard the packet, right? Only the intended recipient will receive the packet and process it for further, right? So, if more than one stations trying to access the channel at the same time, right? Say for example, this diagram, see both A and C will try to transfer the packet at the same time, right? So the collision will occur. So both the data packets will be lost, right? Both the data packets will be lost. So there is no possibility of retransmission in the case of random access protocols, right? Random access protocols. So if you look at the random access protocol, there are different types of random access protocols. We'll be starting with Aloha. Aloha again classified into uh, two types: pure Aloha, slotted Aloha. So pure Aloha, the total transmission time is continuous, right? So the whenever you have data to transfer, the station sends a frame immediately. It will not wait for data to accumulate, right? Whenever a data is ready to transfer, right? If collision occurs, the data frame will be destroyed, right? Or lost. So no retransmission is possible, right? Um, Slotted Aloha, it's a improved version of pure Aloha. So a station can start transmit its data frame only at the beginning of a time slot. See, the data, the channel will be divided into number of time slots, right? If you have a data to transfer, you can uh, start transfer the data only at the beginning of the time slot, not at the intermediate of the time slot, right? So if you have a data at the intermediate of any time slot, then you have to wait for the next time slot starts, right? Only at the beginning of the time slot you can transfer the data, right? Again, this is also there is a possibility of collisions if two stations trying to transfer the data at the beginning of same time slot. But it is better than pure Aloha, right? Pure Aloha. Uh, so here is a example for pure Aloha. The stations on the wireless Aloha networks are a maximum of 600 kilometers apart. If you assume that signals propagates at 3 into 10 to the power 8 milliseconds, right? We find propagation time is equal to 600 into 105 divided by 3 into 10 to the power 8, which is equal to 2 milliseconds. Now we can find the value of uh, TB for different values of k, right? Different values of k. For k equal to 1, the range is 0, comma 1, right? The station needs to generate a random number with a value of 0 or 1. This means that, right, the back of time is either 0 millisecond or 2 milliseconds. Right? So, for depending upon the k value, the back of time will also vary. The vulnerable time is nothing but the length of the time, right, for the entire transmission time. So, the time taken by the source device, the station, to completely transfer the data, right, uh, is equal to 2 into frame transmitting time, right. Slotted ALOGA, it's an improved version of pure ALOGA, right. So the next one is carrier sense multiple access, right. Carrier sense multiple access. So to minimize the number of collisions in ALOGA, right, uh, we go for carrier sense multiple access, right. Carrier sense multiple access. See, as the name suggests, carrier, before accessing the channel, you have to sense whether the carrier is ideal or busy, right? You have to identify whether the carrier is or channel is ideal or busy, right? So that's why they name it as sense before transmit or listen before talk. So CSMA that way can reduce the possibility of collision, but it cannot completely eliminate the collisions or congestions, right? So the vulnerable time for CSMA is the propagation time, that is TP. So this is the time needed for signal to propagate from one end of the medium to the other. It is called propagation time, right? So uh, CSMA is based on persistent methods, right? Persistent methods. So there are three types of persistent method: one persistent, non-persistent, n persistent, right? So persistent method is simple and straightforward. See, whenever you find the channel is ideal, we can start transfer the frame immediately with the probability value of 1. This means that there is a highest chance of collision, because if two or more stations trying to send the frame at the same time, right? So one persistent method, uh, you will be following the same back of time, right? So all the stations will be uh, backing off to same probability value. Say for example 1. So 1 second you will be backing off if the channel is busy, right? If the channel is busy, you will be backing off to 1 second, right? In the same way, all the channels will be backing off with a probability value of 1, right? So whenever so after 1 seconds, you will come back and see if the channel is ideal or busy, right? So if the channel is ideal, then you can start transfer the data immediately. This is called one persistent method. Whereas non-persistent method, the only difference is you will be backing off for random amount of time. So if the channel is busy, right, you will be backing off for random amount of time, right? There are a number of algorithms to generate this random waiting period, right? So the concept is, if the channel is not ideal, right, you are going to back off for random amount of time, right? Random amount of time. So after waiting for this random period, you can come back and check whether the channel is ideal or not. This is called non-persistent method. The third one is p-persistent method. So p-persistent method is actually the combination of one persistent and non-persistent method. See, this method, after the station finds the station, the line is idle, right? So whenever you find the channel is idle, it will start transfer the data with the probability p, right? Then the second step, with probability Q equal to 1 minus P. Before transmitting the second frame, it will wait for the uh, beginning of the next time slot and checks the lines again. So after transmitting the first frame with the probability value of P, before transmitting the next frame, it will wait for the beginning of the next time slot and checks that line again, whether it is ideal or not. If the line is ideal, then it goes to step 1. That means it will start transmitting the second frame. If the line is busy, it will go for back off for a random amount of time. So this is called P persistent model, right? So these flowcharts will illustrate the three types of CSMA methods: one persistent, non-persistent, and P persistent. So in one persistent is simple. You are checking whether the channel is ideal or not. So if it is ideal, you can start transfer. If it is busy, you can go back and check channel is free or not. Whereas in non-persistent model, you are including one more component, random waiting period. If the channel is busy, you can wait for random amount of time, then go back and check. Whereas P persistent is a combination of these two, right? So you are checking the channel is busy or not. If it is busy, go back. If it is ideal, you will transfer first frame and wait for the slot and checking the channel again. If it is busy, go back for back off. If it is ideal, you can start transfer the second frame, right? So CSMA, the next one is CSMA CD. That stands for carrier sense multiple access with collision detection, right? Collision detection. See, uh, uh, if a station in the network willing to transmit the data, right? It will sense whether the carrier is ideal or not, right? Ideal or not. If the channel is ideal, it will start transfer the data, right? Start transferring the data. So if more than one station is trying to transfer the data at the same time, collisions or overlapping will occur. So the data will be lost, right? So imagine if you have a huge number of stations are present in the network. If more than one station is trying to access the channel at the same time, then there is a high chance of collisions, right? So how to identify first uh, whether the channel is ideal or not, right? So basically the energy level, right? Energy level will be energy level present in the carrier will be used to identify whether the carrier is free or not, right? So basically the data will be transmitted using some sort of electrical voltages, right? Electrical voltages. So some voltage for 0, some voltage for 1, right? If there is no electrical signal is present in the carrier, that means the carrier is free or ideal, right? So based on the energy level which is present in the channel, we can sense whether the carrier is ideal or not. So uh, in case of ideal, there will be no electrical or energy level present in the carrier, right? Uh, in case of smooth transmission, you can sense the uh, unique or unchanged level of energy, right? Whereas in the case of collision, you can feel the high level of energy or abrupt changes in the energy level. So these are the three energy levels which are present in the carrier, right? So uniform or unchanged energy level, right? Abrupt changes in the energy level in case of collision, no energy level in case of ideal, right? So throughput for a pure Olaga, slaughter Olaga, and CSMA-CD. So for pure Olaga, it's almost 25 to 30%, whereas for slaughter Olaga, it's all 50%, right? And for CSMA, depending upon the persistent method you are using, the throughput will go from 50% to 90%. Right? And the next one is CSMA CA. Right? CSMA CA is actually invented for wireless networks because we are using a common medium, right? Not a dedicated medium, right? Uh, and it uses three strategies to avoid collision. The strategies are interference space and contention window acknowledgements. See, this simple animated video will explain how collisions may occur in case of wireless networks, right? So there are two clients, client 1 and 2, trying to access the access point at the same time, trying to access, sending the transfer the data at the same time, right? So the collision occurs at this access point, right? So in order to avoid this scenario, it uses these three strategies to avoid these collisions, these sort of collisions, right? So interference space, contention window, and acknowledgements. So before transferring the uh, data, first the source device have to send RTS message. RTS means request to send. Right? Before transferring the data, we have to send a request message, request to send signal to the destination device. So if more than one device trying to send the data at the same time, you can identify by sending this type of messages. RTS is a small request message or control message, you can say. Right? So if RTS message, upon receiving the RTS message, the destination device will send a clear to send. That means the channel is free. I am also ready to receive your data. Uh, you can transfer your data, right? So clear to send. So upon receiving the clear to send, you can now transfer the data from the source to destination, right? So once the data transfer is over, final acknowledgement will be transferred from the destination to source device, right? So this will reduce the collisions abruptly in the CSMA protocol, right? So that's all about random access protocols. Then next video we'll talk about uh, controlled access protocols, right? So if you want any further clarifications in the random access protocols, you can post it in the comments. We'll talk. Okay? Thank you, guys.